I'm pretty sure it's recording.
We're going to have a talk about mass and weight, because in physics they're quite different things, and we need to be really correct with how we use our language around mass and weight. So colloquially, we say, how much do you weigh? And we expect someone to give us an answer in kilograms. But when we're in physics, we separate out mass and weight. And that asking people how much do you weigh, and the answer being in kilograms, is just a hangover from when we used to measure weight in pounds, and then it really was a weight. But now that we've changed to measure in kilograms, we're measuring mass and not weight. And so we haven't really, we think we've got things sorted in science, but some of the basic nuts and bolts aren't there. We haven't really worked out what mass is yet. There's two conflicting theories. Either that mass is the amount of matter that's present in a body, so the more particles you've got in a body, or the more massive it is. The other conflicting kind of theory is the resistance of a body to being accelerated, and that's the idea that a bus is harder to accelerate than a car because it's got more mass. And so they're two different ideas about mass, and we are only just starting to build an idea of what actually causes mass. What is it that gives different bodies, different objects, different masses? Weight, on the other hand, is relatively easy. Weight is the force that acts on a mass due to the acceleration of gravity. And for us on Earth, in Year 11 science, gravity is 10 newtons for every kilogram of mass, which means there's an acceleration of 10 metres per second squared for every single object. Doesn't matter how much its mass is. So that's that amazing thing that you can drop two different bodies that have very different masses in the same height, and they'll hit the ground at exactly the same time, like that classic experiment of climbing the Leaning Tower of Pisa and dropping different objects off, and they hit the ground at the same time.
Oh dear. Oh Lord.
I reckon a paper airplane would look the same time as a bowling ball, so I reckon.
Who was the other hand up?
Kind of the same.
Same question. So can anyone explain why the paper airplane falls?
Terminal velocity. Oh my god.
There's other things affecting it, it's aerodynamics. If it's a very non-aerodynamic paper dart, it might fall slower because there's a large force of air resistance working on it.
I was
So
talking about theoretically in a vacuum.
if we say that air resistance is negligible, is the word. So things like a feather, when you drop a feather, it wafts down quite slowly because on a feather, air resistance is not negligible. It's got a tiny mass and a huge surface area. It's like a kind of built-in parachute, and so it falls really, really slowly because it's got big air resistance, small mass, so air resistance is not negligible. And so if weight is just equal to mass times gravity, and that's a really similar equation to our F equals ma. All that we've done is instead of putting a there, we've replaced the a with a g, and g is the symbol we use for the acceleration of gravity. And so on Earth, the acceleration of gravity is 10, or when you get next year, it's 9.8, and then next year, it's 9.81. Just gets more and more accurate. On the Moon, it's about 1/6 that amount. And so when you go to the Moon, your mass stays the same, but the pull of gravity gets